Okay, PQR and which one? PQR and SQP, is it? PQR and SQP? The first
Yeah.
one. You want to prove that they're similar. So I'm looking at PQR. I take out my highlighter. I take out SQP. SQP is over here. SQP. Okay, then this one. Okay, if I call this X, this one will be X. Then if this is X, RPQ. RPQ is what? What's RPQ? RPQ. Let me say I call this Y. This one will also be Y. Okay. Then PRQ. PRQ will be the same as SPQ. PRQ. Oh, that rocks. This one is also X. Because these two are also alternate segment theorem. The two X, right? Let me erase this one. The X and X are the same because of alternate segment theorem. Y and Y are the same because of alternate segment theorem. That's why you have two pairs of corresponding equal. Is it okay?
No, wait. I don't even understand like how you guys got
Okay.
the.
Okay. Alternate segment theorem is otherwise known as the tangent chord theorem. So the angle between the, okay, can you see that to this circle, right? There's a tangent here. Tangent.
Yeah. Yeah.
So
Yeah.
the angle between the tangent and the chord, this angle is the same as the angle opposite the chord.
Yeah.
Okay? The tangent chord theorem, or basically the alternate segment theorem. Tangent chord theorem. Do you remember this theorem? What did we
Yeah,
learn?
I think I see it now. It's
Yeah.
okay now. Yeah,
Okay,
yeah.
let me make it better.
That's okay.
Okay. Let me draw, okay, red color. I draw the red color line, and then I draw this one, tangent chord. Okay. Then you see this red color angle and this angle the same. Is it okay?
Yeah. Yeah. Yeah.
Okay, then I draw the blue color line. I draw a blue color line. I draw a blue color line and the same chord. And can you see that this angle and this angle the same? Both
Yeah.
are Y. Can how?
Yeah.
Can how? Okay.
Then
Can.
it's okay. Yeah.
Have I answered all your question?
There's that question 3, part 2.
Question
Yeah.
3, part 2. Okay, question 3, part 2. Okay, question. Erin, you chew a while, huh? Sorry. After Danielle, I go to Clara very soon. Okay, AE bisects FEC. AE bisects FEC. So this is topic 11, question 3, part 2, asked by Janelle. Okay, so I see a tangent here. Then there's a chord. So I call this angle X. That means this will also be angle X. Is that okay with you?
Okay.
It's also alternate segment theorem or the tangent chord theorem. Then I see this chord, same line, and then another line. Can I say that this angle Y will be angle Y here?
Eh?
Can I? Okay. Then part one, does part one use part two use what's part one, is it? AE bisects FEC. 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 So this is X and Y. So is there anything I need to use from part one? Give me a sec. Angle AEF is the same as angle BAE. 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 Where's BAE? Okay, angle BAE plus angle ADE. Angle AD. Angle AEF. Okay, what's angle BAE? What's angle BAE? Angle BAE is the same as angle BEA. Oh, okay. This one is also X. Wow. Wow, no, so sneaky. This one is also X. Because these two, right, is equal tangent. These two are equal tangent. This one and this one equal tangent.
Mm.
So that's an isosceles triangle you're looking at. Okay. So then, okay, then not so bad. So from here, if I want to find this angle, right, is the same as X plus Y also. Okay.
Oh, exterior.
Correct. Angle triangle. So this one is the same as X plus Y. Is it okay?
Okay.
Hello? Okay. Have I answered all your questions?
Yeah, I think it's okay.
Can. Okay. Then I answer. Okay. Clara. Okay. Clara, I check your question. Okay. Erin, sorry. I go by. Okay. Clara only got 2 questions, so don't worry. Very fast one. Clara question. This one yesterday I got go through. Quite an interesting question. Clara, are you there?
Yeah.
Okay.
Only need for like the parts with like the circled one.
Very interesting question, this one. Okay, so this one, okay, this one is quite okay. Okay. Okay, for part 2, is it?
Yeah.
This one, okay, very simple. You see 90-degree, right? Then you ask yourself, okay, 90-degree, if the triangle is right angle, then it has to be quite restrictive. So that means it has to fulfill, for example, Pythagoras theorem. Right. So I ask myself, okay, let's say if I want to have a triangle, angle D, right? Say angle D is 90-degree, okay, let's say angle D, angle E, let's say 30-degree. Then EF, angle F, this one's supposed to be 9 cm. DF supposed to be 3 cm. So I ask myself whether it's such a triangle. Oh, shucks. Okay, so I ask myself whether it's such a triangle possible. So then, Clara, okay, you see, if let's assume that if you have such a triangle that's possible, okay, one of the things it must fulfill is from JH2 math, we know that if there's a right angle, it must fulfill Torcaso, right?
Yeah.
So look at this. If I consider 30, right, this will be the opposite. This will be the hypotenuse. So by right, if such a triangle exists, right, if such a triangle exists, right, then you should have, then by Torcaso, you should have sine 30-degree equals to 3/9. But you know that sine 30, this is equals to half. It's not equals to 3/9. Right now. So this triangle cannot exist. Is that okay?
Yeah.
Cannot. Okay. Your camera never on, so I cannot see your reaction. Can I? Okay, so I go to B, Okay. Are
Yeah.
you copying, right? Is it? Okay, then I wait a while. Are you copying or? Okay,
Yeah, okay, I'm done.
Can I? Okay. So, but quite okay. Okay, so, this right. Okay, this one. Okay, so you see, if the two triangles are congruent and they are of the same area, the starting point, right, is I'm going to use the area. Okay, so, this triangle, right, which is AYX, okay, these two are equal, right? Then you draw the line, they also draw. Yeah, how come you draw, you shading? Okay, so this one, red color, red color. Okay, so now you see this one, right?
Yeah.
Okay. Let's say those sides in with the dash, right? Let me call them R, for example. So R. Is that okay, you?
Yeah.
Can I say that the area of the blue triangle, which is area of AXY, can I say that is half A B sine AYX? Can I say that?
Yes.
Okay, can I say that the area of triangle? So you notice why did they tell me this? In math questions, every word sentence has its purpose on now. So they don't give extra things for fun. So I realized, oh, okay, they give me this, confirm I got use one. So if they tell me area, a natural starting point is, oh, you go and write out the area formula and you see where it gets you, right? So AYZ, which is the red triangle, can I say that it's half A, B, sine angle AYZ?
Yes.
Can now? Then they tell you that they are equal. What does it mean? It means that these two are equal. These two are equal, right?
Yeah.
But so if I cancel half r square, it's telling me that sine AYX is equals to sine AYZ. However, they are not equal angles there because the question says that they are not congruent. If congruent, then it makes sense they're equal, but they are not congruent. But so it tells me that AYX is not equals to AYZ since the two triangles not congruent, right? They are not congruent.
Yeah.
So what does it tell me? When two sine ratios are equal, if the angles are not equal, then they are basically supplementary because sine positive can be first and second quadrant, right? Sine can be first and second quadrant. So it is telling me that, okay, that means this guy, my friend here, is probably AYZ, right? Is probably going to be 180 minus AYX. Because first and second quadrant.
Okay.
Yeah, okay,
Yeah.
so a lot of things I bring in. Topic 9, topic 13. This tells you what? Angle AYZ plus angle AYX is 180. They lie on the same straight line. Right?
Okay. Yeah.
Oh, very easy.
Okay.
Okay.
No. Okay.
Oh, sorry. I'm too fast. Okay, I wait a while.
Yeah. Thanks. Okay. Yeah.
Okay. You look like you're pressing your iPad. You do a screenshot, is it? Oh.
Yeah.
So I go to the next one. Okay, so not to worry, I recorded, just that the downloading takes a while. Okay, so part 2. Okay, part 2, right? If I'm not wrong, okay, am I right to say that you got one answer only? Then you're wondering how come the question got 2 answers?
Wait.
The one that you circle.
I think I don't think I knew how to do like at all. Yeah.
Oh, use sine rule. Use sine rule. Yeah, you use sine rule. Can do already. You use sine rule. Question 9.
Okay.
Cannot?
Yeah.
Okay, let me see. Okay, let's say if I tell you, yeah, you use sine rule. Okay, so this one just draw a diagram out. So you see bearing of B from A is 300. So you draw A, you draw the north arrow, then B is 300. So it's probably something going to look something like that. This is point A. Point B is going to be somewhere here. So this is going to be 60 degrees since this is going to be 300. And B is due north of C. So C is south of B. B is due north of C. That means C is south of B. AB, this is 800 meter. AC, this is 700 meter. Okay, find the possible bearings of A from C. A from C, right? Okay, so you know that this is also the north arrow. They are asking you for this angle. That's all. Can So after that, that means you see a triangle. Does the triangle have right angle or not? Have? Good. So Pythagoras. If the triangle got no right angle, sine rule, cosine rule to find unknowns. So that's the decision algorithm Okay. So after this triangle, how do you find this, right? Okay, so you can just do 800. Let's say I call this theta. 800 over sine theta is the same as what? Sorry, it's the same as, oh, wait. This is 60 degree. Okay, because of alternate angle. 60. Okay.
Oh, okay. Yeah.
700 over sine 60. After you do this, right? Okay, like cooking show like that. 4 minutes later, you should get this dish. Okay, 0.898989743. 9899743. Then here it tells you that there are two answers. There are two answers. Okay, so because sign is positive, you check first and second quadrant answers both make sense. So a lot of students, because I jumped to conclusion, a lot of students who asked me this, they were like saying, hey, how come I only got one answer? 081.8. The second answer is actually 098.2, which is basically 180 minus. You subtract 180. It's the second quadrant. Okay, huh? So just
Okay.
when you do this question, this will be the question you are facing. Okay?
Wait, how do you know when to like include like the second quadrant though?
You always include unless it defies the question. Example, you include it, then you realize that it cannot, the angle don't add up to 180.
Okay.
You know? You always include. Okay?
Okay.
You give extra, they can minus off, but you don't give, then they, okay. So that's the, okay, then next one is B, right?
Yeah.
Yeah, okay. B, actually, you did it before in JH2. So you remember in JH2, this is like one of your quiz question. Okay, so it's a very fun question. Okay, so what you do, right? Okay, have you taken a screenshot?
Yeah, I did.
Yeah, okay, so I just put one side. Okay, so B. Okay, so B, right? Very simple. Okay, you look at the red triangle, then you look at the blue triangle. Okay, very good. You put this as Y. Let me call it something else. Maybe call it, okay, let's call it Y since you put Y. Okay, put Y together. Okay, so if you look at the red triangle, can you say that tangent X is the same as H over Y?
Yep.
You look at the blue triangle, can I say that tangent 25 degree is H over 2Y?
Yeah.
Very easy one. This one is simultaneous equation. You did it. You have this question in your JH2 quiz. So from both sides, I can say that H is Y tangent X. H is 2Y multiplied by tangent 25. Equate that. Y tangent X equals to 2Y tangent 25. Answer Y on both sides. Your tangent X is just 2 tangent 25 degree. There, done already. Yeah.
Okay.
You know?
Yeah.
Right. Okay. Let me check if I answer all your question.
Yes.
Yeah, yeah, okay. So can all good.
Okay. Thanks, Mr. Tan.
Wrong. Okay. So just don't need to say bye. Anytime you will just feel free to come in and leave. Okay. Can okay. So now next one is Erin. Okay, Erin, sorry to keep you waiting for such a long time. Okay, Erin is gone. Okay. Erin, are you there? Okay. Erin Tan prep 1, question 1. Okay. Okay. So time prep 1, question 1. Okay. Okay, Erin, sorry to keep you waiting for so long. Okay, so next one, this one. How to know that AC is the longer side? Oh, that's a good question. I also don't know. Oh, 100.1. Okay, let me see. Let me see. I draw the diagram out. So I got A, I got B, I got C. AC is 14 cm, AB is 10, ACB is 32 degree. Okay. Then I want to find angle ABC. Okay. Then 10 is 32. So if I use sine rule, I got angle ABC equals to 47.892 or 132.108. If angle ABC, then BAC will be equals to, so BAC could be equals to 47.892, or it could be equals to 100.108. If it's 100, yeah, there's no way to know. How will we know that?
Something like the answer sheet said that the answer is 132.108 because
Because AC
if
is the longer side, right?
because AC is the longest side.
Yeah, I'm looking at the solution as well, but I can't see it. 14. Okay. I know why. Okay, so you see, if okay, this one I think need to back test. It's not easy. You imagine if this is 100 point something, right? If this is 100.108, right? That means this angle, right, is going to be 180 minus 32 minus 100.108. That means this angle is going to be 47.892. Okay. Doesn't sound right. ABC. If ABC is so it, then this cannot. Let me see if an ABC is 47.892, then BAC will be 100 point something. Why is this wrong? Can I get back to you? Yeah, can I get back to you? Yeah, I don't know because it's modified, so I don't know whether got any information missing or not. Yeah, there could be a part that's missing. Yeah, that they never mentioned. Let me go and check the test paper again. This is 2022 quiz, right? I get back to you this one. Can I? I don't know. I feel something missing. Okay, this is done prep 1, question 3, part 3. Okay, what's bothering you for this question is part 3, I guess. So, tangent theta is negative 3k. Okay, I want to find. Oh, okay, can. Okay, why?
Wait, I got tangent theta equals to k over square root 1 minus k squared.
Tangent theta equals to square root a minus.
Wait,
You use part 1.
yeah,
Okay, so your tangent theta. So from part 1, you got tangent theta equals to.
k over square root 1 minus k squared.
But how do you know that tangent theta is positive? You may not know it.
Oh,
Theta is negative because when I look at this, right, if they tell me k is positive, right, tangent theta is negative. So it tells me that theta is in the third quadrant. Sounds right, right? That means this is telling me that, no, sorry. Tangent theta is negative. And here, sine theta is positive. That means there's a negative sign here. Am I right? That means, sorry, I changed. Theta is in the second quadrant. Because sine positive, tangent negative. Okay? So these two points to me that these two are pointing to me that theta is in quadrant 2. So from here, negative 3k is equals to negative k square root 1 minus k square. Cancel k on both sides. 1 minus, cancel negative sign on both sides. 1 minus k square. 1 over 1 minus k square is equals to 3. Square root 1 minus k square should be equals to 1 over 3. 1 minus k square equals to 1 over 9. K square should be equals to 8 over 9. K should be equals to plus minus square root 8 over 9, which is the same as plus minus 2 square root 2 over 3. Now, since K is positive, that means K is equals to 2 square root 2 over 3. Right? The reason because K has to be positive, given by the question. Let me see if I'm correct. Yeah, I'm correct. Yeah. That means what you gave me is useful also. Yeah, without this, I wouldn't have solved the question. Okay, so next one is time prep 1, question 5, part 3. The rest of you, if you all got question like Maddie, or don't worry, just ask. Oh, you can text me, you can Zoom chat. Everything okay? Can I? Okay, so I will go on to the next one. So the next one is where we are. 1, 2, 3, 4.
So actually, how do you square root 8 over 9?
Sorry?
How do you square root 8 over 9?
How do I square root 8 over 9?
Like you can
Okay, so for example, this one, like, so okay, K squared is 8 over 9, so I just square root the entire lah, square root 8 over 9. So square root 8 over 9 is the same as, yeah, it's just the same as square root 8, square root 9. Then like all good certs, right? I mean, 9 is a nice number, so it's just square root 8 over 3. And again, being a person who like to simplify the certs, right? You break it down, you know that you like to break it down a cert, you pull out a perfect square. So this is the same as square root 4, square root 2, right? I mean, after a while, the cert just become very natural. Like you naturally look for perfect squares, isn't it? Boleh ya? Okay. Can I? Okay. So this is topic 1, 8 time prep 1, question 5, part 3. You're supposed to find the, oh my God, what question is this? Oh, this looks so hard. Wow, I hate geometry. Okay. So this one is time prep 1. Okay. So this one, okay, let me see. Okay, so you know that AX, I want to find X because this one has to do with AD. Is AD a diameter? Is AD a diameter? Would AD be a diameter? ABC lah, should
For
be.
X, Y, I use the area of triangle YCE, but then I don't know how to find the area of triangle DX.
Angle DXA. Okay,
I mean the area, yeah.
area, let me think. I have to start from beginning. Sorry. Okay, YCE. Okay. Angle YCD is angle YX, 2 times angle YXC. Angle YCD, this one is the same as 2 YXD. This one is twice of this. Okay, so that means, right, earlier on, have we proved something? Okay, C and O. Oh, C and O are the centers. Okay, cool. This is the center.
Why is Y?
So that means this is the diameter. That means this is the diameter. Okay, AD is a diameter. So this one, right? Angle at center, 2 angle at circumference. Angle at center, 2 angle at circumference. Can you see the same arc shoots an angle to a center, shoots an angle to a circumference?
But it looks like angles in the same segment.
For angle the same segment, right? It's a butterfly with equal wings. Equal wings.
Oh,
All 4 points will be like on the quadrant, like a pond skater like that. Okay?
it
Like
cannot be like diagonal.
cannot. So this case, right, you can see this doesn't go to the circumference. This one, right, is an arc shooting the same angle towards the center, so an angle to the circumference. So this and twice of this lah.
Okay.
Okay, can okay. Okay, then after that, so I believe YCD you found earlier, is it? YCD you have found earlier, is it? You have found. Am I right to say that YCD is something you found earlier?
Yeah,
Can 66.422,
yeah.
Therefore, angle YXD would be 33.211. Okay. Then since this is a diameter, right? Because they say that C is the center, right? So you know that this will also be 90 degree. Fair enough. So therefore, okay, this angle would be 90 minus this angle, right? Would be 56.789. Yeah, not very fair. It's more than 2 marks for sure. Something wrong this one. Should be 4 or 5 marks. Okay, This is also 90 degree. Okay. Now BX, I believe you found it earlier as well. Is 3.6661. You found it earlier in the question. Am I right to say that BX is the same as BY because of equal chords? This one, BX, right, is 3.6661. So now you look at this triangle, right? You got 56.79. You use Picasso to find your AX.
Oh,
Can but I think the question should be 4 marks, not 2 marks. It should be some typo. Sorry, let me the revision package always call a lot of mistake. Can? Yeah, I'll pause here for a while for you to absorb the question. And you okay? Then I'll go on to the next one. Oh, you have a lot of questions, That means your holiday must be fruitful. You must have been doing a lot of math.
finish all the time practice.
Wow. You have spent your national day well. Oh, she said finish, then she zao already. She disappeared. We are Maddie. Okay. How to identify angles for alternate segment theorem? Okay, why not own method? Draw graph, how many points you label? Maddie, you there? Yeah. Sorry, I just saw a question. Let me see. Let me see. I just post here so that everyone can see. How to identify angles for alternate segment theorem. Okay, alternate segment theorem, right, is basically the same as the a nicer way to remember is also called the tangent chord theorem. You can also call it the tangent chord theorem. Sounds fair?
Yeah.
Let me find something I used yesterday. There was something that I wrote yesterday. Don't know whether it's still there. Oh man. Okay, correct. So basically another way to say is that the angle between the tangent and the chord, okay, like this is the tangent, this is the chord, right? The angle between the tangent and the chord is the same as the angle opposite the chord. Okay, Maddie. So the angle between the tangent and the chord, tangent and the chord is the same as the angle opposite the chord. So that's how I remember it, lor. Okay, so you see that this chord is the key player, right? The chord below it, the angle below in basement 1, and the angle directly opposite right in front, right? These two are the equal. Is that okay?
Yeah, okay, thank you.
Can. So another 容易的方法就是 remember it as tangent chord theorem. Like that might be better. Okay, where did the question go? Okay, then next one. Revision package topic 10, question 3C. Why not own method? Why not own method? So what do you mean?
Wait,
Own method can, any method, your method will draw graph, how many points do you label? Okay, as many as you can, but just take note, if the question asks you to label coordinates of turning point, then you must label. Okay? Axis, right?
like for the x-axis, how many points do you label?
Try to at least 0, pi over 2, pi, the main one. 5个，这5个。
Like no matter like how many like what is the period, is all of like this.
Okay, good question. It depends on the period as well. That's why it's not fixed. So sometimes, let's say for example, the period is 2/3 pi. Then I'll label something like this, 2/3 pi. For example, 4 pi over 3, then 2 pi. Yeah, 有时候是这样的嘛，可以了。For example, cosine, can't remember what graph, something like that. Yeah, cosine 3x, something like that. Yeah, lor. So this will be it depends on the period of the graph as well.
So is it that every time it cuts the x-axis, we have to label it?
If you can, not all the time you can. Okay, so for example, right, if let's say I tell you something like this, you draw y equals to sine x plus 5. The graph will be on top. The graph will be on top. The graph won't even cut the x-axis. Okay, so if there's translation, right, you will not cut the x-axis at nice values. That's why you cannot draw. Okay, but for example here, what will you do? Maybe you just label down, this is pi. You label down, this is pi over 2. You label down, this is 3 pi over 2. You label down, this is 2 pi. And then you label your turning points. 3 pi over 2, 4. Here, you label pi over 2, 5. Something like that.
Is it a must to like label like every coordinate, like the turning point for every graph?
If you don't label coordinate, minimally you must have a dotted line. The dotted line must show what's the highest y value and lowest y value. Either you have this, right? Or you have the coordinate of turning point. My advice is, if you find that it's very confusing, just label coordinate all the time. It will be like insurance. That one guarantee you correct in all scenarios.
Okay.
Can all?
Yeah.
Just remember label coordinate of turning point. If you ever see a graph in the near future, okay, label coordinate of turning point. Confirm safe in all scenarios. Okay? Yeah. And time prep for question 6.
For the revision package, it is topic 9, question 3C.
Question?
I did a different method and the answer was not correct.
Which one?
Topic 9.
Topic 9, question 3C. You did a different your answer different.
Yeah.
Why is the answer different? Let me see. This is the chemistry one.
Yeah, the chemistry one.
Why is the answer different? Is it because you have
Like I found AO and OC, then I used like the formula to find the angle.
formula to find the angle? Can you send me a picture of your working?
Sure, I cancel already.
You can but I don't know. Yeah, the question solution I see got 2 methods, but they never They both got the same answer. You don't happen to have the O working. Don't happen.
I just use FAC to find OA.
FAC to find OA. You just use FAC to find OA. FAC is 35.2. Let me digest the question. AOC. AOC is not a right angle triangle. So it's
I assume that way is FAC equals to OAC.
is FAC may not be may not be
Oh,
Yeah,
then maybe that's where I got wrong.
may not be 不一定
Oh, okay. Then I understand now, yeah.
Okay, then give me a while. I go back to Erin. Okay, Erin is back. Okay, so I owe you time break 3, question 6, time break 4. These two. Okay. Okay, so this one, Erin. Okay, this one, part 2. So given that, so I have angle. So Erin, back to you. This is time break 1, question 7. You have angle A. Angle A is 36 degree. You have AB. Oh my God. Equals to AC. Alamak. Okay. Okay. A, B, A, C. A is 36. D is a point on AC such that BD bisects angle ABC. So this is point D. These two are equal. So that, okay, BC is 1 unit. BC is 1 unit. So that the length of AC is 1 plus square root 5. If it bisects, right, it has to be the full or perpendicular, right? Am I right? No, may not be. May not be. Bisects, may not be. Okay. ABC similar to DBC. Okay. What am I supposed to do here? Does it say anything about bisect? Does it say anything? Time break 1. 7. Okay, ABC is similar to BDC. ABC, if triangle ABC is similar to triangle BDC, this tells me that AB over BD is the same as AC over BC, is the same as BC over DC. Okay. So what am I supposed to do? So BDC is also an isosceles triangle. Okay. So that means ABC, these two are the same isosceles, right? So I know that AB is equals to AC. AB is equals to AC. That means BD is also equals to BC. That means this is also 1. Okay, because this is also isosceles. That means BDC is also isosceles. Okay, then after that, I know this is 36 degree. This would be 180 minus 36 is 144. 144 divided by 2. This is 72. This will be 72 degree. Is that okay? Okay, Erin. Erin, are you there?
Yeah.
Are you following? Are you following this part?
Yeah, I am.
Do you I mean, okay, so BD and BC are the same. They are both 1 unit. Because ABC is similar to BDC, right? BDC is also an isosceles triangle. So BD and BC, right? They are both 1 unit long. Then I want to find AC, right? Okay, I can find using cosine rule. I find DC first. Then I multiply by 2.
Wait, DBC is 36 degrees.
DBC is I don't think so. I think it is 72. No. 36. Yes. Correct. Not. Yes, this is 36. Okay, this is 36. This is 36. This is 72 degree. So what I can do is, if I use sine rule, right? Let's say I call this x and I call this x, or I use cosine rule. 1 square is equals to AB square plus
How do
AC.
you know when to use cosine rule and when to use sine rule?
When do you use cosine rule and sine? Okay. There are specific wordings in the notes that tell you when to use sine rule and when to use cosine rule. Okay, but it's very hard to remember. It's very hard. Okay, so I can show you in the notes. Okay, let me show you. Okay, in the notes, they actually got mentioned. It's just that I will show you, but I can show you, also cannot remember. Because even I cannot, okay, I can remember, but it's hard for students to remember. Okay, so where is it? It's basically here. Okay, this part. The sine rule can be used to determine an unknown if you have two angles one side, you have two sides and one non-included angle. Which is not easy to remember. Okay, then cosine rule. When do you use cosine rule? When two sides and one included angle are given, all three sides are given. Okay, Erin?
Yeah.
Can I show you the official answer, then I show you what I do. Okay. Then I show you what I do. Okay. So what will I do? Well, my common sense tells me that if you give me sine and cosine, right, I always try sine rule first because it's very easy to use. Okay. If I don't have enough information for sine rule, then I will try cosine rule. Okay, then I'll try cosine rule. Okay. Cosine rule usually involve three sides. Right, in your equation, they involve all three sides of the triangle and one angle. Sine rule only involve two sides, two angle. That's all. But common laziness will tell me that sine rule very easy to use, so you always try sine rule first. If you find that you are stuck, then you try cosine rule.
Okay.
Can is that a satisfying answer?
Yeah.
Yeah. Okay. Okay. Yeah. So part two, are you able to do? So will you be able to do part two?
I'm trying.
Okay, you try first. I think once with the information given, you should be able to do. Okay, as you are trying, Erin, I'll go back to Maddie. Okay, so Maddie question was, Maddie, your question is what? Time prep 4, time prep 3, question 6. Time prep 3. Question 6. I'm just pulling out the time practice question. Okay, time prep 3, question 6. Part 1, part 4. This one?
Yeah. Like for part one, I don't understand. Like I don't know why is there like a negative part for it.
Take two possible values of A. It can be negative. Why does it look different from mine? Question 6, right? Question 6. This
Yeah.
question. This 3 times by 3. Okay, the reason is because okay, so here they help you lah. Okay, so it's not like a super scam because they got tell you need to give 2 values lah. Okay, so cos x and cosine negative x, right? They are actually the same graph. When you reflect these 2 graphs, right, you will actually see the same thing. Cosine x and negative, they are actually reflected about the y-axis. They are reflected about the y-axis. Okay, and in a sense, they are symmetrical. They are symmetrical about the y-axis, which is why you will find that if you draw, like, so example, 3 cosine x and 3 cosine negative x, right, you are going to get the same graph because the graph itself, it reflects about the y-axis. You're basically turning the x from positive to negative, right? When you switch the signs of the x, you are actually pivoting all the x values about the y-axis to the other side. Do I sound logical?
But if it's like symmetrical about y-axis, doesn't it mean like the x-axis it will show like 0 to negative 2 pi?
You are not wrong. Just that in this case, right, they did not say who is positive. They did not state the domain, right? Okay, so you see, okay, for example, this diagram, right? This diagram, I can show you now. Okay, let's say I use, let's see, whether I sketch cosine x or if I sketch cosine negative x, I may employ different x values, but you will see that, okay, can you see the graph are the same? I first show you the blue one, red one, blue one, red one. They overlap each other totally. Yeah, totally. Totally. Can you see that they are the same graph?
Yeah.
Yeah, lor. So it's just that, of course, I'm using different x values. But when I reflect that, left and right look the same. If I reflect already, they still look the same. It's like you are looking at your reflection in the y-axis in the mirror like that. Okay, both of them will look the same. Both of them will look the same. Okay, so you can see this part, right? This is this section here. Okay, this section here, right? Cosine x, right? But if, for example, it's cosine negative, then the blue color part will be reflected here. Okay, similarly, the red original part will be reflected. You're just turning them 180 about the y-axis. Okay, but they're the same graph. Okay, ma?
Yeah.
So just part 1, right? Okay.
Wait, Mr. Tan,
Yeah, or part 4.
can you go through the next parts for the same question?
Part 2 also, Part 2 also?
Yeah.
Okay. So let me just write down. This is time prep 3, question 6. Okay. Then state the exact solution equals to -6. So this one, right? For part 2, if I have 6 cosine AX equals to -6, this is the same as cosine AX equals to -1. Okay, so -1 is basically this line, right? I will expect 4 answers. 1, 2, 3, 4. I will expect 4 answers. Okay. So given how this graph is symmetrical, right? This one, they should be pi over 3. This should be equals to -1. Equals to negative. Oh shit, that's wrong graph. Okay. Sorry, sorry. This is 3 cos AX, so I'm being scammed now. Okay. Sorry. 6 cosine AX equals to -6. If I divide by 2, it's the same as looking at when 3 cosine AX is equals to -3. Okay, so every why I do this is because the graph I'm using is 3 cos AX. Is that okay? So you want to see when is 3 cos AX equals to -3, right? And if you look at the graph, right, there are 2 times where it will be equals to -3, one of which is at pi/2, right? Because cosine graph and sine graph, they are symmetrical one. Okay, so it's this guy is very beautifully in the middle.
So it's pi/2 and 3 pi/2.
Correct. It's beautifully in the middle. The turning point is beautifully in the middle. Okay, and you should know it lah. You should know because you know the cosine graph, right? You know where the turning points are. Okay. Now,
Yeah.
part 3, you take a range of values of k for which the 3 cos AX equals to k has more than 2 solutions. Okay, the idea is like that. The idea is like that. Imagine, right, you have 2 graphs. One is y equals to 3 cos AX. And this is already drawn for you, right? The next one is y equals to k. So you are looking at these 2 lines, right? These 2 curves, how many times they intersect? Can I say again? You are looking at how many times they intersect. So Erin, imagine that I draw a line which is y equals to k that goes like this. Okay, and then there's a second curve. The second curve is this one. Right? The second curve is this curve. Y equals to 3 cosine AX. Then I ask you, how many times do they intersect?
4.
4. Okay, so you can see this k, right, should be more than -3, am I right? Because you can see above -3 ma. Right. If I go a bit higher, still cut 4 times, right? Still cut 4 times, right? If I go a bit higher, still cut 4 times, right? If I go a bit higher, still cut 4 times, right? 4 times, right? Can you see? Okay, so you see your k, right, basically must be between -3 to 3. When I reach 3, right, wait, I can include 3. 3 also cut to 3 times. Okay, when I reach 3, right, I will cut 3 times. 1, 2, 3. Is that okay with you?
Wait. Oh, yeah.
But when
Okay,
I
okay.
-3, cannot. -3, no, because it only cuts 2 times. Okay? So
Yeah.
basically, if you see my cursor, right, my k is basically going up and down. Any line here can cut more than 2 times. But here, only 2 times. Okay. Next one. It's cosine A. Yeah, where's the part 4? Okay. Find the number of solutions for 3 cos AX plus 1 equals to 1.5x. So this is part 4. Okay. Okay. 3 cos x. Okay. Not difficult. Do I need to make us? Okay, can. Okay, so this one. This kind of question is important. It's important. You know, like they give you a curve, then they ask you to draw another extra line. Okay, so this one, 3 cos, right? You work backwards, right? This is the same. The idea is that you want to have 3 cos AX eventually on one side, and then your function, another new function on the other side. So this is the same as cosine AX plus 1 equals to 0.5x. Is that okay? Maddie, okay?
Yeah.
This is the same as cosine AX equals to 0.5x minus 1. This kind of question is quite important. Okay, so find the number of solution means basically the number of times they intersect. A lot of teachers like to set this question. So they will tell you, you go and draw a graph, then you go and solve another equation. So the equation, what you do, right? You work backwards. Work until my original graph appear already. Okay, but you see, I'm not there yet. Okay, so what I need to do, I multiply by 3. Okay, so this is the same as 1.5x minus 3. This is the graph you draw. 1.5x minus. So I go to my graph, then I draw 1.5. Okay, 1.5 means how much? 1.5. Okay, negative 3 will be somewhere here. 1.5 will probably cut something like that.
So, Mr. Tan,
Yeah?
why don't you expand the equation?
Extend. What do you mean by
Expand, like 3 multiplied by cos ax and 3 multiplied by 1.
3 multiplied by cos ax plus 3? You mean 3 cos ax plus 3?
Yeah.
That's okay as well. Yeah, no issue. No issue. Yeah,
Okay.
yeah. So it's just that when I do, I won't have the foresight. But on hindsight, I would have just done what you said. I should have done it. What you said. Oh,
Mr. Tan,
yes.
like for the graph for 1.5x minus 3, like the y-intercept you can know from the graph, but like how do you know how to draw like the line? Because if you draw like the way that you draw now, it's like 4 intercept, but the answer is 3. So how do you know like how do you draw it?
The answer is 3. Did I draw 3 or 4? 3 one. 1, 2, 3. Okay. This one, right? 1, 2, 3. 3 intercept. This one.
Like how do you know like what
Okay.
if it cuts like the other curve?
Okay, so what I'll do, right? I will just sub in 2 values. Is that okay? I will sub in 2 values, right? Okay, so for example, you just sub. Okay, maybe this one, right? Okay, negative. This is going to be one of the point, for sure, huh? Okay, so 0, negative 3 will be 1 point. You sub in pi. You sub pi, right? So pi will be y equals to 1.5 pi minus 3. Numerical value. This is 1.712389, which is about somewhere here. Slightly more than half. Is that okay? So this is like pi, comma, 1.712389. Then you draw a line past these 2 points. You confirm safe one. You just need 2 points to sketch a line. Like what you usually do, is the method never change one for all types of questions. Then, so Maddie, to answer your very, very first question, right? To be careful, okay, you must plot 2 points using hard work. Then one of them is the y-intercept. You draw a straight line, then most likely you will not go wrong.
Okay.
And then you should have your 1, 2, 3. Your gradient should be correct. The position of your line should be correct. As long as you plot 2 points carefully and you draw a line past these 2 points, your number of times intersecting should be correct. Can
Yeah.
Okay. So next one. Erin, this question okay, ma?
Yeah, it's okay.
Okay.
Wait, but when I sub in y equals to 3
Y equals to 3.
into my like y equals to 1.5x minus 3. I mean, yeah. Then I got like x equals to 4.
Y equals to 3.
Oh, wait.
1.5 minus 3.
Oh, I have to sub in pi.
You sub in pi because the x values are all okay, ma?
Oh, okay, I got it. Okay, thank you.
Okay. Okay, next one. This one okay, okay, so this
Wait,
is
no, I don't get it. I tried. Then
you try, for which one? Part 2 or part 3?
sorry.
No need, sorry. Don't be so curtsy. Okay.
But
2, okay. Let me just go start from part 2 as well. This is time prep.
part two.
Part 2, Part 2. Okay, let's see. Part 2.
Like after you wrote out the cosine equation,
This one, right? Okay, so part 2, huh? So from here, you know that they are similar, right? That means, okay, you can say, if I use this, AC over BC is the same as BC over DC, right? Is that okay? So you
Yeah.
know that BC is 1 unit. Okay? BD is also 1 unit. So BC is 1 unit. 1 unit. I call this 1 unit. 1 unit, 1 unit. AC, I call it X. DC is basically X minus 1. DC is X minus 1. Yeah, DC is just X minus 1. DC is just X minus 1. Okay?
why -1?
Minus 1. I can also call it half X. No, can I call it half X? Because this is 1. AC is X. Then DC is X minus 1. Is it because AD is 1? AD is 1 because AD is 1. Oh, because these two are equal. Alamak, this is 1, this is also 1. Because these two angles are equal.
Oh,
Yeah, yeah. So that's why it's X minus 1. And from here, you can do a quadratic equation. X squared minus X minus 1 equals to 0. Then you use quadratic formula. Negative B plus minus square root. Hey, y'all, anytime you want to go, don't worry, just feel free to leave and exit, okay? Yeah, so don't be shy. Over 2A. I think you should get an answer from here.
okay, I got it.
Okay. Then part 3, okay, part 3 is actually
Part two, I know how to.
yeah, it's just cosine rule. It's so obvious they put cosine there. Okay. Okay, so next one is this question. This question is Stamp 1, question 9. This question is Stamp 1, question 9. Okay, Edwin, Stamp 1, question 9, part 4. Okay. What about this question? Oh, okay. So I want to find the height of the kite above. It's just part 4 only, is it? Oh, okay.
Yeah.
Already. So I do. Then I directly both R. So this guy fly a kite. I cycle along the path QS. The smallest angle of elevation. The greatest angle of elevation. The smallest angle of elevation. The smallest angle of elevation. Okay, have you found the height above R? Okay, let me see. You have found the height above R. 是不是我想太多啊？Okay. So there's a height here. There's this part here. Okay. Oh, the greatest angle of elevation is 11.6. So like that. This is 11.6 degree. Okay.
How do you draw that?
How do you draw that now? Okay, so this is the kite. This is where the kite is. The kite is on top somewhere here. So this is 90 degree. Yeah, this is 90. It's a 3-dimensional diagram. It's a 3-dimensional diagram. Okay, yeah, it's like pointing out like that. It's like pointing outwards. This like pointing out. Like if you see my camera, like pointing out like that. That's where the kite is. The kite is here. Hmm? Okay.
Wait, I cannot visualize.
Okay. So here, right? Okay, you see this red color triangle, oh? It looks like this one. So it looks like that. There's the kite. The kite is here. The kite is here. Then the boy is looking, the boy is here. The boy is looking here. Then this is the angle of elevation, which is 11.6.
Also, the angle of elevation is from where the kite is, then the
Upwards like that.
off the ground. Oh, okay.
So I'm looking upwards. So this red color triangle, imagine it's pointing out of the plane. Okay? Can Then okay, so 90°. So okay, this distance you can find. Do you know how to find the shortest distance? The one in question mark. You use area of triangle. So half AB sine C is the same as half times base times height. To find this line over here. This is the shortest distance.
Okay.
It's quite hard. Okay, maybe okay. So this question goes like, okay, so first, right, if you look at this triangle, okay, the greatest angle of elevation will come when this distance is very, very short. It's the shortest possible. Does that sound fair? So this must be the shortest distance possible, which I'm going to write over here. It must be the shortest distance to R. Okay? The greatest angle of elevation is like, you remember in class I said, if you go and watch movie and you sit very, very close to the screen, like you're in the front row, your head neck need to be lift up neck all the way. Yeah. Yeah. So the greatest angle of elevation, if the ball is here, and this is the greatest angle of elevation, that means this is the shortest distance possible. This will be 90°. Okay?
So if it's the shortest distance possible, then it's the smallest elevation.
Greatest elevation. We are doing the first part. I'm doing the first part.
Oh, wait, why is it greater?
Greatest, okay, you see, you see when you sit at when you sit at a cinema, right? Okay, cinema screen, right? Imagine you sit here versus you sit here. This is row A. This is row J, for example. Which one do you need to lift up your neck more? Is it J or A?
Oh, A.
A, right? Because you see, you look, right? Wow, you see so close to the screen. No more ticket left. You see, this is the front. This is the biggest. So the closer you are to the screen, the more you need to lift up your neck, right? So the shortest distance between you and the screen, the more you need to lift up your neck. Okay, ma? So this shortest distance, right? I want you to see it as the height of the triangle, QRS. This H, right? Help me to see it as the shortest distance, okay, as the height of the triangle. So the area, right? The area of triangle QRS can be written as half times H times is 144. I find from you 144. QS, what you found? QS, what is QS? 144.37. 143.71. I use the 560 answer. You know, this is also the same as half times, say half sine A 130.8 times sine, what's the angle? 11.6, is it? 11.6. Is it 11.6? Is it 11.6? Yeah, 11.6. No. What angle is this angle? What angle is this? I don't know.
It's
Yeah, you should find.
79.961.
79.961. Okay, can. So from here, you can see that you can make your H the only unknown and you can solve for H. So if you can solve this, you can get your H. Your H eventually should be 78.099. This shortest distance should be 78.099 meter. Okay. Then from there, you should be able to use Picasso to get your height, which is about 16.0 meter. Clara, you there? Clara, are you there?
Yes.
You know, right, when for example, sine theta equals to half, right? Then
Yeah.
theta could be either 30° or 150 because of quadrant 1, quadrant 2. The pattern is that if it's either equals to alpha or it's equals to 180 minus alpha.
Yeah.
All right. Can you see these two? They add up to 180.
Yeah.
Yeah. So just now that question also the same. Just now the question is the same. That question that you asked me, right? This one, right? So it's either, if they are not equal, right? That means, right, they are like the supplementary of each other. One is first quadrant, one is second quadrant, but they both add up to 180.
So like the sine AYX is still equal to sine AYZ.
Correct. Like if you see, you go and try sine 30° and sine 150. Are they the same? They are the same. Both equal half. Because you know why? Sine theta is the same as sine of 180 minus theta, right?
Okay.
Yeah, that's why they're the same. Oh, okay. Sorry, I just saw it.
Okay.
Okay. So
Thank you.
problem. Okay. Then so Erin, I just asked you, okay, let me know if you can get the height of your kite.
Yeah. I got the height. Then what
Okay.
I do?
What do you do? So you got a height already.
Yeah.
Now, okay, just now this is greatest angle elevation. Okay, so Erin, so you look at me. Okay, when the greatest angle of elevation is when the distance between you and the movie screen is very short, right? So if you want the smallest angle of elevation, as you see, I'm pointing here, how far should you be from the movie screen? Is it as near as possible or as far as possible?
So the person will be standing closer to Q.
Closer to Q, is Q, okay, why do you say Q?
Because now he's standing at H, right?
At this point, right? This is the greatest, right?
Yeah, so if it would go like that,
If I
then
go this, okay,
it'll be longer.
this will be longer. Is this the longest I can be from R?
Oh, we can go closer to S and it'll be
Yeah,
longer.
I can go to S. S is the longest. S is the longest. So you go from S, right? Okay. I know this one very troublesome, but I show you. This is imagine there's a green color triangle here. Is 3D. This triangle is 3D. Okay. So think of this triangle this way. The same 16.0 meter where the kite is, right? This is 130.8. This will be your smallest angle of elevation. Okay. It's just like if you are sitting at the back row of the cinema, you don't need to raise your head so much because you're at the furthest distance away from the cinema.
Wait, but why do you have 16.0?
Because this 16.0, right, is of the kite from the boy. So when the boy cycles here, right, he need to raise his neck very high because he's very close to the kite. But when he cycle until point S, he is very far from the kite. Okay, that's why, but remember the kite itself is still 16 meters from the floor, which you found earlier.
I didn't get 16 meters.
Yeah, what do you get?
I got 78.151.
78.151. That means this answer you give me could be wrong. I don't know if I follow this, then
Oh,
your height, okay, the height must be 16.031. Yeah, it depends on this input lah. Yeah. Okay, but you're supposed to get 16.
and then I used my answer for part 3 and got it.
You use your answer for part 3, you got the answer. I don't know, I mean, yeah, lor. Can't see your working, but if this one is high, 16.0, 79.961 is confirm correct. So you this angle, QRS is confirm. Okay, I try. If wrong, I will whack you. Okay, 961 is this one times 0.5 times 0.2 times 130.8. Okay, then I divide by 0.5, divide by 14, 3.71. Yeah, 78. That means this angle is wrong. That means this angle is wrong. Okay, so that means this angle is wrong. Okay, do you know the area of this one? QRS. QRS.
I got
5611.8.
got 5615.56.
It should be 5611.8.
Okay.
You get that? Yeah.
Yeah, I'll just write it down first.
It could be a rounding off error. I'll
Wait,
check. Your calculator is in degree mode, huh?
Yeah, 5641.8.
Oh, that means this one wrong. This one wrong. This is 79.748, not 79.961. 79.748. I think rounding off error 是吗? Rounding off error. Your QRS, yeah, 79.748. 79. Yeah, lor. Could be rounding off error. You use 3 to 5 dp lah, okay?
Okay.
可以吗？小心哦。Okay. So this number should be 79.748. Okay?
Yeah.
The other questions, are we okay to continue tomorrow?
Okay.
I think I cannot finish. Too many. But it's good lah. You're productive. Okay. Will you be online tomorrow as well?
I think so.
Okay. Don't worry. You let me know. Yeah. Sorry, I couldn't answer all your questions.
It's okay.
How many more do I owe you? Let me see. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, I got 6 more. Okay. Okay, let me know whether this question okay, huh? Okay, one of the questions is the graph one I answered already, so I owe you 5 questions.
Wait, what's the area of QRS?
5611.8.
Okay.
After this, I want to answer one more.
Wait, sorry. After I find the height again, what do I do?
After you find the height, right? Okay, so you got 16?
Wait, 16 is
The height of the kite above the field.
for is it
The
K?
sorry, is it
Wait, I
K?
found 78.099. I don't know what.
Correct. This one is the shorter distance, right? Then
Yeah.
you use 11.6 and the shortest distance, Picasso, to find the height of this KR. Let's call it KR, okay? K for kite, to find KR.
Okay.
And maths must be your favorite subject.
No, I'm just really bad at it.
No lah, you're quite good. So negative. Must be more positive.
Okay, yeah, I found the height and then
Okay, so after you find the height, right? So remember this height, it's just like the helicopter, right? Its vertical distance from the floor is the same. Okay, no matter where you're looking at it. So now imagine you are this guy, right? So you travel here, you travel to S, right? So once you're at point S, right, you'll be looking at it from this green color triangle. So S will be here, S will be here. This will be point K now. Okay, and this will be point R. So this is SR. SR will be this distance, 130.8. Right? It's the longest distance possible. The longest distance possible. Okay. Then from there, you can find the smallest angle of elevation. I feel real. 1, 2, 3, 4. Okay, finally I upload my video. Eh, how come my face is gone?
Answer 6.99.
Yeah, correct. Happy for you. Okay. I just take the time to answer one more, okay? This one. Time prep for question something. Question 2. Time prep for question 2, part 5. Okay. This question you see before. Can you see it's very important? You add a suitable graph to your diagram. Time prep for. Okay. I'll let you get ready first.
Okay.
See how this and this are almost similar? This is the guy that you draw, right?
Yeah.
Okay. You write what I write. Okay, write this equation out. Copy down the start point. This one, work backwards. Okay. Bring this to the right hand side. Bring already?
Yeah.
-1 on both sides.
Also, the graph is x over 2 pi minus 2 pi.
Yeah, law, correct law. Can or not? Then I want to ask you, if the graph you want need to draw is minus x over 2 pi minus 2, do you know how to draw this line? Very easy one, very easy one.
Sub.
Sub what? Sub.
Sub.
What do you sub?
I sub y equals to 3.
No, okay, so you see, so Erin, so you look at my screen, okay, look here. Okay, this one very important, okay, so you see when you want to draw a line like this, right, where the gradient is a denominator of pi, so called to speak, okay, when you are drawing this onto your trigo graph, your question, right, you will have been doing something like this one, pi over 2, pi, 3 pi over 2, and 2 pi, something like that, am I right? Correct. So you won't be having things like, x equals to 1, 2, 3. You will not have x equals to 1, 2, 3 whatsoever. So what you do is very simple. You sub x as 2 pi. Can already. Then you can see 2 pi over 2 pi is 1. So first one, right? Very simple. You sub x as 0. Straight away, y is -2. 0, -2. Next, you sub x as 2 pi. Because 2 pi minus 2 pi minus 2 is just -3. Then you get something, I think like -3. So it's 2 pi, -3. That line, you got the line already. Draw your straight line past these 2 points and you are done. Because the pi cancel off. That's why I sub in a multiple of pi as my x. What happened? You're gone. Okay.
Oh, sorry. When you sub
Show me your family
x
photo.
equals to 0,
It's the y-intercept.
0 divided by 2 pi is 0.
0
But
divided
then y equals to minus 2 pi.
y equals to -2, not -2 pi. Alamak, you okay. You start x at 0, what you get? Negative 0 over 2 pi minus 2 is what?
Oh, I wrote
Minus
my
2,
equation wrongly.
yeah. Okay. Minus 2, this is the y-intercept. You go and divide 2 by 2 pi. Oh, itchy back.
Wait, if I sub x equals to 2 pi,
Yes.
then why do your equation have a minus?
Have a because is it minus x? There's a minus x here, right? Is there a minus x from the equation? No, don't have. Sorry. I salah. I wrong. Yeah. So the answer should be what? -1, right? -1. Oh, so it's like that. Sorry. Because the reason is careless mistake. Careless mistake. Okay, so it'll be somewhere here lah, 2 pi comma -1. That means the line will look something like this. Okay, not a nicest line, but something like that. Okay.
Okay. So
And,
there are 1, 2, 3, 4, 5, 6 solutions.
yeah. I don't know. I have not drawn the other graph, but my focus is to tell you how to draw this line lah, or what points to use lah. Okay.
Yeah.
So 重点是 you must know you sub in 2 pi and 0 can already. Why you sub in 2 pi? Because 2 pi divided by 2 pi is a nice number. Can?
Yeah.
Okay. I'll stop here. I very tired already.
So sorry.
No, it's all good. Okay. I sleepy. Okay. See you.
Thank you. Happy National Day.
Happy National Day. Okay.
Bye-bye.
You say you never dance, never perform. Okay, bye-bye.
Bye.
Bye.